In this video, we are starting our section on graph theory. Our goals are to give a formal definition of a graph, to define different types of graphs, draw graphs with given properties, and finally to prove key results about graphs. So in this video, we will talk about what a graph is and give a few examples. So a graph consists of a non-empty set of vertices, V, and a set of edges, capital E. And each edge has a vertex at each end. So the easiest way for me to explain what this is to draw an example. Let's draw a graph, and I'm going to call the graph G1. Okay, so the vertices I'm going to represent with dots. So let's say that there's a vertex A, another vertex B, and another vertex C. So these are the vertices, or I sometimes call these nodes. And anytime I draw an edge, I'm going to represent that with a line. So maybe there's an edge between A and B. So I can either draw an edge with a straight line, but it doesn't have to be straight. It could also be curvy. So maybe, in fact, maybe there's two edges connecting B and C like this. That can happen. And maybe there's an edge from C to itself. We call that a loop. Okay, so this is an example of a graph. One thing I cannot have in a graph is I can't have an edge like this that's not connected to any vertices at the end. That's what this last thing says. Each edge has to have a vertex at each of its ends. And it doesn't matter, where or like how I move these vertices around or how I bend the edges around. So even if I were to draw A over here, and maybe I put B up here, and maybe I put C down here, as long as it's the same number of vertices with the exact same edges, it's the same graph. So as long as there's just one edge connecting A to B, two connecting B to C, so maybe one connects B to C like this, and maybe the other one connects B to C like that, and it's totally fine for these edges to kind of cross over one another. That's okay. It doesn't mean that there's another vertex here. It just means that that's just how it's drawn. Okay, and then I need this loop from C to itself. So I got the exact same vertices, exact same edges. They're just bent in different ways, but that's still the same graph. Still the same graph. Okay, so some notation. I'm going to represent this graph G1 as in this parentheses notation where I write the vertices first and then I write the edges second. So my vertices are A, B, and C. I can write them as a set. The edges, well, there's 4 edges. So maybe I'll denote them E0, or I can call it E0, E1, E2, and E3. So there's 4 of these edges. Let me label E0 as the first edge we drew from A to B. Let's have E1 and E2 be the 2 edges from B to C. And let's have E3 be this loop from C to itself. So the endpoints of the edges I can write. The endpoints of E0 are A and B. The endpoints of E1 and E2, well, they're shared the same endpoints, B and C. So when I have something like this, multiple edges connecting the same set of vertices, that is called a multiple edge. So E1, E2, this is called a multiple edge. All right, and then E3, that was our loop. That was our loop. When you have an edge connecting a vertex to itself, its endpoints, well, there was just one. It was just C. Okay, so we are ready to define the degree of a vertex. The degree is the number of times it appears as an endpoint of an edge. So in my graph up here, what's the degree of A? How many times does that show up as the endpoint of an edge? Well, it's the endpoint of one edge of just E0. So its degree is just 1. All right, what about B? Well, B shows up as an endpoint for this edge, as well as this one. So it shows up as an endpoint of an edge 3 times. And then finally for C, well, that shows up as an endpoint here. Here's the second time. Here's a third time. And then for loop, it happens one more time. And I count both of those. So for C, its degree is 4. Okay. All right, so a graph that has no loops or multiple edges is called a simple graph. So the graph that I drew up here, it had both of them. It had multiple edges and loops. So that one's definitely not simple. Here's an example of a graph that would be simple because it doesn't have either. It doesn't have loops and it doesn't have multiple edges. So let's express the vertices and edges of the simple graph as sets. Okay, so recall that when we do that, my notation is I have this parentheses. I have this big old parentheses, and I'll put a comma in between. And then first, I'll have a set where I list all the vertices, or I will write all the vertices first. And then after that, I'm going to have a set where I list all the edges, all of the edges. So my vertices, well, I see three of them. There is H, there's I, and there's J. Cool. And then for the edges, well, I'm going to denote the edges by what their endpoints are. So there's one edge connecting H to I. So I can write that as, well, H comma I. There's one edge connecting those two. Comma, and then there's another edge connecting I to J. So I can write that as a set with I and J in it. So that indicates that there's an edge connecting these two vertices and an edge connecting those two vertices. Okay, so this can look kind of, tedious to do this, but that's one of the ways to describe what the graph is without having to draw a picture. Okay. All right, so let's flip it to the next page here. So I want to end the video by talking about directed graphs and undirected graphs. So a directed graph is a graph where each edge is given a direction. And an undirected graph is a graph where the edges do not have specified directions. So in the graphs that we looked at here, this one was G2, this one was G1. Well, there was no sense of, directions that we were giving to the edges. So those two graphs were undirected graphs. Okay, now let's do an example where we get a directed one. So the example says, let's make this graph G3, that's to the right, become a directed graph by specifying directions for the edges. So right now, there are no directions specified for the edges, but I can specify some. So maybe for this edge right here, maybe I'll specify with an arrow pointing this way that it is going like this, that the direction is progressing up to this vertex that's up above. Okay, and then maybe I'll say that for this edge, the direction is this way, so I'll draw an arrow. Maybe for the reverse of that multiple edge, maybe it's going the other way. Doesn't have to be, but I'll just pick that one. We got one more edge, and let's specify this as a direction. So that's one possible way to make this a directed graph. Okay, so this is just a brief introduction to what graphs are, taking a look at a few examples. So over the course of the next several videos in this section, we will introduce many other types of graphs, and we will slowly prove key results about these different types of graphs.